Okay, so here we go into surface treatments and finishes. Very exciting. I'm going to go through this in different material areas. We're going to start with polymers. So yes, here we go. First step with polymers, luckily there's not that much you can do to polymers. It really just comes down to applying decals, a bit of color, or buffing it up. And then this is what we can see here. So that's what we call buffing wheel. This is literally just fabric wheels that spin around very quickly, and you can see there the bit of acrylic or whatever it is that's being polished, and it gets very, very shiny. It does take a while though, but it does work very well. Yeah, and that's why I've sort of said it. I mean, buffing wheels can be used on metals and plastics, but yeah, you can use it with a sort of polishing compound like Brasso or something like that. So that's a good way. That's an effective way of polishing up some acrylic. Now, the other one is flame polishing here. Now, this is particularly good for acrylic sheets. Now, the reason being is this can only work on thermoplastics because, if you remember correctly, thermoplastics are the only ones that react to heat, so they soften and they can melt. So what this does is where the flame is firing onto the acrylic, it's actually slightly melting the surface of the acrylic there, which is good, but it also can cause some problems. So for example, if you've got a square of acrylic like this and you're applying heat onto the edge like that, now the issues can start because you're melting the acrylic. They can start getting problematic. Let's say the dimension here is 100 millimeters and it's been laser cut. Now, if you apply heat all the way around, once that's been heated, it might shrink down to like 99.95 mil or something. Now, if the dimension is critical, that might not be so good, and that's just because it melts the acrylic. Yeah. So, excuse me. That's really the only things you can do for polishing. You can do thermosets are okay. The trouble is they don't react to heat, and it's often heat that kind of actually helps to polish. But if you're using a buffing wheel, you can use a buffing wheel for things like epoxy resins. So that's where if you're doing like a lovely table pour or something, you can get this very, very shiny. And that's just by working the surfaces down to sort of micron levels of finish, because yeah, thermosets are just very, very durable. Okay, so next one is printing. Now, these are actually two different GIFs here in a video, so they're not showing, but this technique up here is actually called pad printing. And you'll see on the slides, the way this works is you have a soft sort of spongy material there, and what this does is it picks up the ink, and then it will then plant it down onto the products that it's printing on. Because it's soft, it can achieve a 3D like a 3D shape, so it can apply the ink onto a 3D shape. The other one is silk screen printing. So this is where you have a silk screen which has like a gap in it for the artwork to be applied through the product. So when the inks run over the top, it only goes through the gaps. So for example, if I've got a silk screen here and I've got the letter H has been sort of demarcated as being where the ink is going to go through onto the paper, and the paper will go underneath like that, or whatever the material is. So the silk screen's put over the top, and then ink is then washed over the top of the silk screen. And then what you get afterwards is once the material comes out, you'll then get you'll get the resultant ink transferred onto the material. And that's a method that's used for all sorts of things. Like they use it for clothing, but also you can use it for like most materials, really. Yeah. So the only downside of pad printing is that it's a little bit slower. It's not quite so appropriate for mass production, whereas pad printing is. Okay. On to vinyl decals. Now this is really satisfying. So sometimes you see cars that have sort of, for example, they have like sticker material stuck on, or they call it vinyl, put onto it. Now these are cut out using either a laser cutter, or laser cutters tend to burn the material a bit. So actually what they have instead is what's called a plotter cutter. Now a plotter cutter works very similar to a laser cutter in that it has an X and Y axes. So it's still like, it's still got XY movement, but instead of a laser, it has just like a little blade, and so the head of it, it's just got this sort of little cone thing that comes down, and then it's got a very, very tiny sharp blade, underneath. And then this is attached onto a gantry, and then that gantry enables the blade to be able to move sideways, so it moves X and Y. Sorry, can move along the X, and then the paper or the material you're feeding through is then rolled through forwards and backwards, and that provides the Y movement. So it's actually a very good and very quick way of cutting out sticker material, and you can get very crisp cuts on it. Spray painting is another one. Now, this is great, but 3D prints are only as good as the quality. Now, as you hopefully will know, 3D prints are made up of lots and lots of very, very thin layers as the printer builds up and up and up and up. Now, the trouble with that is obviously to hold up overhangs like this, 3D printers actually have to build or print support structure. So for anything overhanging, they have to print support structure. Otherwise, the whole print will collapse on itself. Be a little bit like trying to put a building up without any scaffolding. The whole thing it'd be like trying to build it in midair. So you'd find that all this would actually have a very, very messy, very complicated support structure that's put into place by the software. Now that obviously all has to be removed, and that can leave nasty witness marks. So then you have to do sanding after that. So you've got to sand down the 3D print once that's been done. Then you have the primer layer, which is what's being done here. So primer, this is like a sort of a sticky layer that's put onto it. And primer can be sanded down. You can use nice like wet and dry paper, 1,200 grits, and with water as well actually is preferable, because then that releases the polishing compound from the paper. That way you can get a lovely mirror finish on a 3D print, and then what you can do is then put on your top coat. So this might be a color. If we took an X-ray through a 3D surface, or actually no, let's just say a cross-section of a 3D printed surface that has been painted, right? So let's say this is like a mirror finish you got on here. It's a beautiful, like really shiny, and it's reflective. It's a perfect surface, like what we call an A-class surface. Now the way to achieve that is underneath here, imagine like saying we're looking under a microscope, you'd see the steps of the 3D print, and that's the layering that 3D printers have to do to achieve a three-dimensional shape. So that ends there. And this is annoying because the reason that happens is because every time the bed moves down, the printer then prints the next layer of the print. And so you end up getting the stepped effect. So to get a 3D print really shiny, what you have to do is actually cover up those steps and sand them down, stroke, cover them up. So what you end up having is primer fills up these gaps here. And that's why it's quite thick and tacky. So the purpose of the primer is to first of all fill up the gaps, but then you get like another couple of layers on top of that, which then is the ones you sand down and get really shiny. Then after that, you can put on your beautiful top coat, whatever that is, like chrome finish or something. And that's how you get parts to look really, really perfect from 3D prints. Now, another one is additives. So polymers can have various additives to help them do certain things. Now, probably the most fundamental of all these is what's called a UV stabilizer. If you look at this garden chair here, this is a classic look of a chair that's seen better days. You can see here where it's all faded and it's gone really nasty. And often what happens with these is you actually end up getting not only sort of blotchy and faded color, but you also end up getting a degradation of mechanical properties. I'm going to write that down there, degradation of properties. So what I mean by that is it becomes less durable, definitely less tough. And the reason for it is effectively, this is sunburn on plastics. As the sun's rays come down, or the UV comes down, UVB particularly, it literally degrades the polymer chains and then they become brittle. And after a while, that's when you end up sitting on a chair like this and you have the unfortunate and embarrassing moments of where the chair might break underneath you. Not because you're stupendously heavy, but more because the plastic has just degraded over time. It's become brittle. So that's one thing. So you really, well, sorry, two things really, because you get the faded color and you also get it turns the plastic brittle. You do also get an effect called, which is similar to that, called age hardening. Now, this just happens even if plastics are not out in the sun. This is just when plastics are very, very old, they do become brittle as time goes on. And that's why I've written at the top there, plastics degrade over time. So to reduce that effect, you can essentially add sunscreen to plastics, and they are added in whilst the granules are being melted down to be fed into the machine. They'll add in UV stabilizer, would just be like a little sort of granulated chemical, and that's melted down with the plastic granules, and then it's sort of bonded in. So that's one thing they can do. And obviously they also add pigments. Plastics are seldom left in their raw state. Raw plastics are a sort of rather nasty milky white semi-translucent color, which is not terribly attractive. So you have pigment on literally all plastics. Yeah, because otherwise you have a really nasty color. So they add that in. Now, they have to be careful not to add too much. So if too much is added, it can change the composition of the plastic. It can actually degrade it. Then the other one, which is actually really nice, is with mass production techniques like injection molding and blow molding, you actually get a situation where the injection molding or the blow molding tools, they actually can be self-finishing because parts come out already colored, textured and polished. They don't need anything doing to them afterwards. Looking at this DeWalt drill here, you can see actually we've got like a nice sort of slightly, I don't know, like spotty matte texture there. And the same on the yellow here. And then we've got a kind of like a pearlescent finish there, and then we've obviously got different pigments and dyes and colors, and then they've got areas where they put stickers on as well. So they actually, what they do is they actually use pigments here to create what are called color splits. And these are really attractive. These are done mainly for aesthetic reasons, not really for functional ones. Color splits are always nice to do in design. The way these work is the rubber, the black rubber grip, is actually done as part of a process called two-shot molding. Now what this means is the manufacturers will mold the yellow section first, and the yellow section will typically be made from ABS. So they'll injection mold the ABS parts first, then they will very quickly put that molded part into a different mold, which will just have the cavity for the black TPR, thermoplastic rubber. And then they inject that thermoplastic rubber over the top of the already hot ABS part. And what happens is that the heat bonds them together. Because they're both thermoplastics, the heat bonds them. So that's why you find like grips like this can never come off the parts. And it's because they're heat bond or thermally bonded. It's a nicer way of putting it. Thermally bonded to the ABS. Okay, right. That is it for polymers. So after that, you can have a go at the practice questions. Well done.